Fascinating, isn't it? How normal yet unique our little planet really is. But where did it all begin? When did it all begin? My Christian upbringing has taught me that the Earth, as we know it, isn't more than 6,000 years old. But is it really that young? I wasn't sure, so I conducted a small experiment. Here, in the Netherlands, beneath our feet, we can find coal. This is surprising, as it really shouldn't be there, considering that coal is formed in tropical climates. So, not here in the Netherlands. Then why is it here? And how does this help my experiment? Coal is formed by layers of peat, dead, deoxidized plants at the bottom of swamps. New layers stack upon one another and push each other downwards. The further down, the higher the pressure and temperature. By the reduction of water and increase of carbon, the peat slowly transforms into coal. This process takes place in tropical climates located around the equator. This means that this country wasn't always where it is today. Due to tectonic plate movement moving in an average of 3.5 centimeters every year, the landmass we now call the Netherlands has been moved over 5.8 thousand kilometers north. If we divide that distance to the speed at which tectonic plates move, we discover that, in order to have coal here in the Netherlands, the Earth must be at least 166 million years old. But what about the Bible? Have my parents and teachers been lying to me for all these years? How old is this planet really? Is there even an answer? I want to know. And you know what? I will take this opportunity to find that out. For thousands of years, people assumed the Earth was as old as we are. But how old are we? Our journey to the true age of our planet starts here. And it all begins with this man here, Archbishop James Ussher. His most famous work, the Annals of the Old and New Testament, would form the basis of the search for the true age. So what did he do? Well, Ussher calculated the age of the Earth by adding up all the ages of the offspring in the Old Testament. But his research wasn't that simple. He spent years calculating the exact date on the basis of abundant sources of information, not just the Old Testament. He studied ancient Egyptian and Hebrew texts, analysed how ancient calendars were devised, and consulted with astronomers. With all his findings, he concluded that the Earth was created on Saturday evening, October 22nd, 4004 BC. Today, this number is laughed at by many, and not without good reason. A good counter-argument is that Ussher assumed the Bible was 100% literal and correct, something we aren't so sure about today. But what those people forgot to realise is that Ussher's method of research was the height of scientific scholarship of its time, and he was using all the available evidence. So his work wasn't necessarily nonsense. In fact, his methods are still being used today. In the 17th century, at the time of the scientific revolution, geology became important as its own separate science. Geologists started looking into remarkable geological phenomena, of which the different visible strata, or layers, in rocky formations would be very important for the answer to the true age of the Earth. In 1666, Danish anatomist Nicholas Steno was dissecting a shark when he noticed that the teeth of the shark closely resembled the so-called tungstones that were sometimes found in rocks. The tungstones are named after their triangular shape that looked like the tongues of dragons and snakes in images of that time. But Steno thought maybe these tungstones are in fact real shark teeth. He thought that the real teeth could have been replaced by minerals over a long period of time, thus keeping their original form. But how were those teeth getting embedded into rocks? Steno thought that sediment in large bodies of water would form layers on the bottom. New layers would get on top of the older ones, and everything in between, like the shark teeth, would be locked in. In Genesis, the first book in the Bible, is the story of the Ark of Noah. The ark that would protect Noah and his family from the great flood. The flood that would destroy all life on earth, because the people that lived on it were evil in God's eyes. Because Christianity was important to many scientists of that time, a lot of them looked for connections between their observations and the Bible. For example, in the Apennines, Steno saw that there were no fossils in the deeper layers, whilst the upper ones were filled with them. His explanation was that the deeper layers came from before the Great Flood, and the upper layers from after it. Despite all the critique on this explanation, Steno certainly wasn't the only one to try to reconcile geological observations with the Bible, because a century later, the German geologist Abraham Gottlob Werner came up with his own ideas. He argued all rock was probably formed in the oceans, most likely during the Great Flood. This happened due to precipitation of sediment and minerals underwater that accumulated and thus formed rock. This theory is known as Neptunism, named after the Roman god Neptune, the god of the sea. But many were not in agreement with Werner. The Scottish geologist James Hutton argued that rock wasn't formed in the oceans, but that the heat from the Earth's core is behind it all. And he believed that the Earth perpetually is being formed. Dirt and rocks erode and are swept into the sea as sediment, where they are slowly compacted before they are transformed into new rock by enormous pressure. This pressure also twists and turns the new rock and thus forms new rocky formations, or in other words, new land. This theory is known as Plutonism, named after the Roman god Pluto, the god of wealth. A couple of years after Hutton came up with this theory, he found supporting evidence in a few rocky formations, of which the most famous, Sychar Point in Scotland. Not only were the layers here just on top of each other, but also perpendicular to one another. Hutton argued that only an enormous amount of pressure and time could have formed this formation, a whole lot more than 6,000 years. From 1790 to 1830, the so-called Neptunists and Plutonists stood opposite of each other. However, new findings in volcanism and rocky formations fitted better with Hutton's theory of Plutonism. When a student of the Neptunist Abraham Werner, Alexander von Humboldt found evidence that rocks such as granite and basalt could in fact be formed by volcanism, Neptunism, after a long time, disappeared entirely. Here, in this office, around 1900, a young Polish woman would change the world forever. Inspired by her father's work as a scientist, she went to study physics in Paris when she was 24. Not long after, in this very office, Marie Curie would discover the emission of ionizing radiation of materials, better known as radioactivity. Through the discoveries of Marie Curie, the American physical chemist Willard Frank Libby discovered that the radioactive isotope known as carbon-14, or C14, could be used to date archaeological findings. Isotopes are particles that have the same number of protons as the original element, but a different number of neutrons. Not all isotopes are radioactive, only the ones who are unstable. Unstable means that the particle decays over time. We call these unstable isotopes radioisotopes. Our air consists 78% of nitrogen. When the sun emits radiation into the air, it hits the nitrogen atoms and changes them into carbon-14 atoms. These unstable atoms have a half-life, the time in which half of all C14 atoms have decayed, of 5,730 years. Because new C14 atoms are constantly being added due to radiation from the sun, and because these C14 atoms are constantly decaying, there is a constant concentration of C14 here on Earth. It is a constant value of 0.0000765% of all carbon atoms, the remainder being the actually stable C12 variant. This C12 and C14 ratio in the air is taken up by plants. These plants are then eaten by animals. The ratio does not change when it passes into the animal. This animal is then eaten by another animal, a cycle of which spreads the concentration of C12 and C14 further and further. At the moment, an animal dies and the concentration of C12 and C14 is trapped in its body. The value of C14 atoms is still the same as that of the air. But if parts of the body are preserved, underground for example, we can collect those remnants and count how much of that 0.0000765% is left. This way, we can determine the age of that animal or other organisms, even if they died over tens of thousands of years ago. This new method completely changed our view on the age of the Earth again. Instead of the Earth being thousands or maybe hundreds of thousands of years old, we could argue that this number could be in the millions or even billions. However, we cannot fully trust this method of carbon dating because we do know that the Earth has had the same carbon-12 and carbon-14 ratio for over 30,000 years. But we do not know if that has ever been different. So we cannot determine the age of the Earth precisely with this method, but the assumptions do very strongly point to an older Earth than we previously thought. As we can see, this new chapter of science at the start of the 20th century gave us lots of new insight to determine the age of the Earth. Another very important discovery was made by the Norwegian explorer Roald Amundsen when he measured the coordinates of the exact magnetic North Pole. Oddly enough, this magnetic North Pole is actually on Antarctica, the South Pole. This is because Earth's magnetic field the field that protects us against all kinds of nasty invisible things from space, and the one that powers our compasses, is actually upside down. So the magnetic North Pole is on the opposite side of the geographic North Pole. But this wasn't always the case, because what Amundsen saw was shocking. He saw that his coordinates differed about 50 kilometres from the last measured coordinates back in 1831. Since this discovery, we've been closely monitoring the movement speed of the magnetic poles. In Amundsen's time, the poles moved at a speed of about 10 kilometres per year. But it's speeding up, and it goes on until the poles are flipped completely. This process is continuous and repeats itself about every 300,000 years. And you can feel it coming. This information gives us yet another interesting method of determining the age of the Earth. It starts with the formation of a rock. The rock is formed by magma that has all sorts of magnetic particles in it. This magma then cools off and solidifies into a new rock. Just like with magnets, this rock has its magnetic south pointing to the Earth's magnetic north. And so, if we carefully dig up the rock, we can observe its magnetic poles, and thus determine, with the assistance of carbon dating, when the rock was formed and how old the Earth is. Although these new methods were revolutionary for their time, there was a huge problem. In order to measure the age of rock, the rock must be in almost perfect, untouched condition. But the Earth doesn't sit still. Its convection currents are churning around the Earth's plates, forming new crust and recycling the older crust into the planet's interior. This means that rock from the Earth's beginning is very hard to find. But in the early 1950s, the American geologist C.C. Patterson tried something different. Space. Patterson used meteorites to measure the age of this planet. He knew that meteorites in space aren't affected by any deteriorating processes, so they are almost completely untouched. He also knew that meteorites were formed from the exact same materials as the Earth is, and that this happened at the same time as Earth's formation. In 1953, in Meteor Crater, Arizona, Patterson took samples of the 45-meter-long meteorite that had crashed into Earth, creating this spectacular crater. He dated the samples and was amazed with the results. The meteorite was a staggering 4.5 billion years old, which meant that the Earth too must be 4.5 billion years old. Who knew that the best answer to the Earth's age is not even on Earth itself? Of course, not everyone agrees with scientific findings. Some people think that there is more to it than meets the eye. Even today, after a long history of geological discoveries, there are still some who believe in rather strange alternatives. Or are they? Creationism. Creationists believe the Earth wasn't formed naturally, but in fact created by a higher entity. The largest group in creationism are the Christian creationists, who believe that God created the Earth. Within this group are young and old Earth creationists. This has to do with the interpretation of the first chapters of Genesis. that describe the creation of the Earth in 6 days. Young Earth creationists take this as literal. But with all scientific findings pointing to a far longer time than that, the old Earth creationists suggest that it was meant figuratively, that one day maybe represented 10,000 years or more. The second alternative theory, the intelligent design theory, is even more liberal than creationism. They say that the Earth is so complex that something has to have thought it through, a designer. They reject the idea that our existence is very coincidental. They think that our ancestral history is way too precise for that, and that something or someone has to have planned our path. Are we real? Or are we part of a simulation? Considering the fact that computer technology has taken such enormous strides in the last 40 years, creating magnificent artificial intelligence and fake realities, it's not a crazy thought that we could program a copy of our universe within the next millennia. So, what are the chances that we're living in such a simulation ourselves? That chance is pretty big. But if it is true, we can never know how old the Earth is, or better, when the simulation started, or the simulation that made our simulation. It can go on forever, without any answers. So, how old is the Earth? I'm afraid to say that we do not know. Sure, science can prove that the Earth is at least 30,000 years old, but as long as there is a chance of this simulation theory actually being true, this number holds no value. But we don't know. And maybe we'll never know. Because the more we know, the less we know. But you know what? Maybe we shouldn't know. Maybe it's a sign to focus on more, well, current problems. But hey, it surely is an adventure. Thank you.